In this example, they're asking us to take the second derivative of a function g with respect to t, where the function g is given by t squared e to the negative t. So the first thing that we have to keep in mind is g of t is actually made up of two different functions, the function t squared times the function e to the t. So we're going to have to use the product rule when taking the derivative. So the first derivative, g prime of t, is equal to the derivative with respect to t of our function g, which is just t squared times e to the t. So again, we're going to have to use the product rule on this. So let's leave the first function alone, just rewrite it t squared, and then we want to take the derivative of e to the t. And then we're going to leave the second function alone and take the derivative of t squared. So let's keep going. The derivative of e to the t with respect to t, we have a formula for this. It's just e to the t, so we just leave it alone, plus e to the t times the derivative of t squared with respect to t. Now we can use the power rule here, and the power rule says that we multiply the 2 down and we subtract 1 from the exponent. So this becomes times 2 t to the power of 2 minus 1, which is just 1. So t to the power of 1 is just t. And we can simplify this, if we want, into e to the t. We can common factor out an e to the t from everything, and this becomes t squared plus 2t. So this is the first derivative. Now they said that they would like the second derivative, so what we need to do to calculate the second derivative of g with respect to t is to now take the derivative of the first derivative. So we need to take the derivative of this thing, the thing we just calculated. So this, the second derivative of the original function g, is the derivative of what we just got, e to the t times t squared plus 2t. Now again, this derivative is going to involve the product rule, because here we have a function e to the t, and here we have another function t squared plus 2t. So using the product rule, we say let's leave the first function alone, e to the t, and take the derivative of the second function, t squared plus 2t. And then we're going to add what would happen if we left the second function alone, t squared plus 2t, and multiplied by the derivative of the first function, e to the t. So let's take care of this. The first term is just e to the t again, times the derivative of this thing. Now the derivative of this thing can be broken up into two separate derivatives, the derivative of t squared and the derivative of 2t. So the derivative of t squared, using the same power law that we did up there earlier, is just 2t, and the derivative of 2t is just 2. Plus, now the second term is t squared plus 2t times the derivative of e to the t, and as we mentioned before, this has a formula. The derivative of e to the power of t is just e to the power of t. And again, we can common factor out the e to the t if we would like. There's an e to the t in both terms, so we can common factor that out, and we're left with 2t plus 2 plus t squared plus 2t. And of course, we can combine this 2t with that 2t, so we finally get e to the t is equal to t squared plus 4t, because 2t plus 2t is 4t, plus 2.